All right, so we're on quadrant 2. So for quadrant 2, we need to plot this point. When we plot, like a regular coordinate, -6, 3, we are going left 6 and up 3. From our origin, we're going to trace the path of left 6 and up 3. This gives us a quadrant 2 angle. Remember to go back to the origin to complete your triangle. Here is your right angle. Theta is always anchored to the origin. Now, if you notice, we can't really have a negative side length, but because we're in quadrant 2, our sine, cosine, and tangent values are going to change slightly, or some of them will, based on the fact that this is going to be a -6 because we're in quadrant 2. So I'm going to leave the negative there. I know you can't have a negative side length, but the negative represents the position in the coordinate plane being in quadrant 2. The first thing we need to do is Pythagorean theorem or circle formula, whichever you prefer, to get that radius. So I have x squared plus y squared equals r squared. We're finding that radius, which is the diagonal, which is also the hypotenuse. When you square your x term, when you square your -6, you have to remember that a negative times a negative is a positive. So if you're going to be calculator dependent, make sure you put parentheses around it. This is always going to give you a positive number. Squared numbers always give you a positive number. 3 squared is 9. And when I add these together, I'm going to get 45 equals r squared. And then I'm going to square root both sides. And that gives me the square root of 45. Now, 45 isn't in simplest radical form, so I would want to break this down. When I break down square root of 45, I would use the perfect square of 9 times 5. So this should give you 3 square roots of 5 for your radius. Okay, so over here on the side, where I have my radius, we're going to use 3 square roots of 5. Now we're ready to do our sine, cosine, and tangent. And since we already talked about the fact that those ratios really, truly work, we can do this super fast. So the sine is y over r, and that is going to give me 3 over 3 radical 5. Now, the first thing that I would do to simplify this is I would reduce the 3's. So I would reduce those and get 1's. And the second thing I would do is multiply the top and bottom by radical 5 so that it's rationalized. So on the top, I end up with 1 radical 5. And on the bottom, I end up with 5. All is well. For cosine, it's x over r. And my x value is -6. And my r is 3 radical 5. So what I would do here is I would reduce my 6 and my 3. And then I would rationalize. Multiply the top and bottom by radical 5. Now, this gives me a -2 radical 5. And this gives me a 5. It's negative. Cosine is negative here. Hold that thought. Tangent. Tangent theta is y over x. My y value is 3. My x value is -6. And when I reduce that, I get -1/2. So there you have it. Sine, cosine, and tangent. Sometimes they come out nice and pretty. Sometimes you have to rationalize them. Sometimes they come out as perfect squares. And sometimes you just need to deal with that radical. Make sure that you're following directions there. And what you should know is that in this answer, we have a cosine negative and a tangent negative. Hold on to that thought.